today I will show you how to design a steel structure compare with Etab software and the Rfem for eurocode 3. Now let's start with Etab software. Open Etab. We have to design a purlin support tile for the row structure. So now we have to open new model. Click on the new model, and we have to create the new model from the new material. Okay, and we have to change for number of 5 meter for the direction X. Now we have to we want to design in X direction. We have to select on click only, and we have to view in the plane or Z plane. So we have to view in the elevation 1. Apply. Okay, and I had to close this window. I want to show only this window. Now we have to create new material, under material, add new material, and for my region China section available. Now we have to select on the China section. You select on the steel and the available grade. We have to use the minimum grade steel 275 megapascal. Click on OK. The density of the steel, elasticity, and we can check for the minimum yield strength 275 and the minimum tensile strength. Now we have to continue to other step. We have to define a section, because our section is a thin section, not available in the standard section. Now we have to create new one. To add new property, we have to create this section type, what a shoot type. We call it shoot 50 multiply 100 millimeter multiply 1.3 millimeter, and the material strength is 235 and the tile section is this shoot. Now we have to change the total depth to 100 and width to 50 millimeter, and the thickness 1.3, and for the corner radius we ignore. We have to consider only the thickness of the tube. Now we have to continue to other step. Let to model the structure. We have selected the frame, and the type is the tube 50 multiply 100, and we have to draw it. Now I want to select on the quick draw beam. It's easy because we have to create already a grid line. Steel tube I create for the steel tube from here to here. Now we have to assign for the restraint, joint restraint. I have only select only pin, and for the analysis lane I consider only for the 2D frame analysis, not for the 3D frame analysis. We have to select on the is plane only. We not consider out of plane reaction. Click OK, and now we have to apply load. I select all beam. I select on assign frame load distributed, and the load it the concrete tile. The density of the concrete tile is 40 kg per square meter, so it is equal to 0.4 kilonewton per square meter, and multiply by the width of this purlin is 0.7 meter. So it is equal to 0.24 kilonewton per mètre length on this raster. Now we have to apply, and for the line load on rows, for the eurocode is equal to 60 kg per square meter is equal to 0.6 multiply with 0.7 is the width or the base of the raster, and we have to apply. Because we not just select, we have to select it again. Press Ctrl G, the previous select, and apply. Okay, now we have to define a load combination. Add new combination. You can menu load combination in here. Now I have to define it automatically. Just select on the steel frame design and convert to the user combination. Now you can change this name to DL. This one is the DL plus LL, and this one is the 1.35 DL plus 1.5 LL, and for this one is DL plus 1.5. oh sorry, now you have to change the design code first before you create combination. Now I have to select on design and still revise reference. I want to design in eurocode, not in the China code. Now we have to change in the tab, select on eurocode 3. Now we have to select on the default nationality, not focus on other nationality. So we have to click on OK, and we try to generate load combination again. We convert it to user combination. You can edit it. There are. So you have to check it even with your design criteria or not. DL plus LL, and this one is the 1.35 DL, and for the last one is the ultimate limit state combination 1.35 DL plus 1.5 LL. Okay, everything here is clean and clear, and from the one support to other support you can consider the restraint at the top, because we has add a shoe 30 at the top of the raster. We can support the task, so we have to consider it in the design. Now let's to input this parameter directly in the design still, and retrofacing, or you can select on the review and revise. And breathing, okay, you can add here. It's equal to 0 is equal to from the one should still should 30 multiplied 32 other is 0.3, so we have to 0.3 divide 5 is equal, okay, 0.6 for the unspread length ratio, and for the unspread length ratio at the minor is the same. Okay, now we have to analyze this, and I show it as steel beam design eurocode 3 shield. I'm sorry because my laptop don't show the full screen as your laptop because I use a MacBook. Now you have to check warning. We have the warning information, error not detect. You can check here. It has another condition. You have to modify your frame again, and everything here change the warning is not error. So we have to check the moment at the ultimate limit state. Okay, so the value, okay, it's around 2.61 61 2.09. okay, now I have to design still. I check it again, it's a eurocode 3, okay, and design still, and select a design group. No, we don't have group, we have only one frame, and design again, still frame, select combination or automatically combination for the ultimate state, and design, still frame design. We have to start design and check. You see here, you see here, the section is too slender, the section is too slender, and the combination, the critical combination is the ultimate ultimate limit state is 1.35 the load plus 1.5 the load, and the station at the maximum moment, yeah, the maximum negative moment, and the section is too slender, and Etab not designed for this steel section for eurocode for the strain condition. So this section is not designed in the Etab. We have some problem here. Now we let to design it in the turbo Rfem. Now let's start the turbo Rfem. We have to verify which software is available for the eurocode steel design for the slender section, for the thin section, which one is good for for your project. Now we have to compare the Etab with the ball is the European standard or the European software. It originated in Germany. You can check more detail in the official website of the global Rfem. Now the later version is 6.0. I use 5.25. We had to create the new model, and I tie it to the steel raster 5 meter length. Okay, and this type of structure and not consider unless in the 3D. We do it the same in the Etab as we showed you previously. We have to consider onto the plane itself only, and for the direction of the global axis we consider it upward in the Z direction, and the default national index we keep it the default. We not use other national index, and the design code according to a design combination according to eurocode 1990, and the load combination create automatically. Okay, click on OK. Now we have to create new section. I select this icon and select this icon. I had to create a section 150 1.3 1.3 1.3 1.3. Okay, and the material is still grade 250 55. Okay, you see here 150 1.3 1.3 1.3 1.3 still grade. Okay, now we have to create 1 to 5. Okay, you can tie here 5. Okay, and you can continue to tie other 5, and you can continue tie other 5. So you have 3 segment 5 meter length. It's the same with the model in Etab. Now I have to escape the model, and I have to add new support from here, and the hinge support. Okay, it's stable in 2D frame analysis. Okay, now we have to create load case. We create the load case 1 is the safest. Okay, and for other load case it light load. Okay, import load. Okay, import load. Okay, now we select on the load combination is automatically created. You see here. Now you have to select on the save as. I want to apply the linear load on this member, add new member load, and you have to input the same in the Etab. Okay, have to check Etab again. For the load it's 0.28. Okay, I apply it the same. 0.28 for the load. Okay, now you have to correct this load direction. I select all and control and click on the load. Now you have to change the direction. Okay, and for the line load, okay, I select here and add new, and you can check the load in the Etab again. It is 0.42. okay, minus 42 kilonewton per meter. It's the same. Okay, everything is complete. You have to save your model, and in the calculate, you have to calculate all the all combination, all locale will be calculated and design. Now we have to wait the software running, and you will see the result. Okay, now you can select on the combination what you want to show, and I select here for the by. You see here it's the same result with the Etab. Okay, okay, it's the same result with the Etab. It's 2.10. okay, with the Etab is okay, it's 2.61, and here the maximum is 2.1 at the middle, and for the earth is 2.62 minus 2.62 is the same. Okay, it's the same with the Etab result. Okay, everything is the same for the moment. Now we have to continue to design. I select on data 3 and select on the middle, or I have to select on here design still and design for the eurocode 3. Okay, now for the member, I have to design all member, and for locomotion I want to design only for the load combination. If you want to use other locomotion, you can select the icon for the all locomotion, and the material you have to check yes, this material is correct, and the cross section is correct. Okay, you see the section property this here for the cross section type, cross section height, width, thickness, everything is this in here. And in terms of lateral strength, you can add here. Now for the case I want to design it as a set member. Okay, I don't want to design it for the single member. I want to create new, and this member is a beam. And I have to select it all. One. Okay, one. Okay, I have to select it all. 1, 2, 3. This member is 1, 2, 3. Okay, okay, and description is beam. Okay, this set member is 1. Okay, now we have to check a lateral strength, the cross section lateral strength. We click the lateral strength type is not a lateral and torsional strength. It only the upper flank. Okay, but for the subsection it's not affect much on the structural design analysis. But now we have to just to add it as the same structure in the construction side at the upper. Okay, now we have to add this section at the upper, let understand now. Okay, let draw upper restraint. Okay, and the location it is equal to check in the Etab. It's 0.06. Okay, 0.06. 0.06. Okay, and okay, set a member. Now you have to check it again about your distance. If you take it the relative distance, and if you untick here, you can check. So from the this shoot 30 to 30 is equal to 0.3 meter. It derived with our concept because at the top of the raster we have other shoot to support the concrete tile. Now you have to select relative. Okay, everything here is defined. We have to define it all with our concept. Now you have to select on the calculation, and you see here the result is 0.89%. 0.89. So it means that this structure is passed. So for the deliverable Rfem, the result is design available, but for the Etab, the result design is not available. So you can check here for the eurocode. So you have to check. Okay, the result is 1.078, but for the deliverable, the result is passed. Now you have to check which software is available for your design code and for your section. Now you have to check here. Okay, the maximum value is 0.89. Add here. Okay, add here. As the result, you can compare with the software available or suitable with your project, with your code, with your section. I recommend you use Drupal or other professional design software for eurocode for design sim section or still section in eurocode. For the Etab itself, you can check the analysis and design method compare with other software. And for other sim section, Etab will not design. Okay, will not design. If you correct this section from 1.3 to 1.1 or 1.2, this software will not design this section. But for the deliverable, we design for you. So you have to check which software is good for your project and for your code. You have to understand here. Thank you for your watching. Thank you. And you can check the design result at here. Okay, you have to click on here, or you have to select from the previous add-on module. Okay, you can check one by one the design load test. The load combination that control this design is the ultimate limit state load combination 1.35 the load plus 1.5 light load. And you can check here our cross section by cross section material. Okay, the description for the material you can check here. For the material, cross-section property, you can check here. The design formula, you can check here. Okay, you can check everything from here. The location or each segment on the member. Okay, you can check here. Same for the vertex.